We're going to simulate the four-person push line that we saw in the video. We're going to use machines to represent Ankit, Jared, Jackie, and Neil. And the planes are going to flow through the line, obviously, sequentially. The planes are going to be represented using brown balls. The task times are assumed to be exponential at each station since the operators are human. Just to show you, for example, Jackie's station is assumed to have a processing time of 28, an exponentially distributed processing time with a mean of 28 seconds. And Neil's station would be 14 seconds exponentially distributed with a mean of 14, and Jared exponential with a mean of 22, and so forth. So the modeling is reasonably faithful. We're going to run this thing slowly initially so we can just observe the balls flowing. And to do that, we just change the run speed here. We're going to, in fact, run it for 3,600 seconds because we need to watch this line in operation for a good deal longer than we did in the movie. And we don't want to hang around for 3,600 seconds or the hour. So let's take a look at the detail here. We're going to zoom in on Jackie's workstation. And you can see there's build-up work in process in front of her station, and the balls are flowing through. Now, the speed of the simulation can be increased, and if I do increase it, you can see the actual run time up here, and we're going to run it at full 3,600 seconds. So if I zoom out, you can see that Jared has a significant work accumulation, but Jackie also does, and because Jackie's unable to clear her buffer, she in fact represents the bottleneck workstation. Notice how Neil's buffer is clear. One of the nice things about the software is you can estimate the utilization of the workstations. Both Jared and Jackie are very highly utilized, and it's relatively unimportant that Jared appears to be have a higher utilization than Jackie. Jackie is in fact the bottleneck. Right, let's complete the entire simulation run by really cranking up the speed. We've now run 3,600 seconds. And we're able to go down and have a look at Neil's station and see how many planes crossed his disk. We have a look at the statistics here, and we see that in fact 131 planes crossed his station during the hour. So the throughput estimate of the line is 131. It's close to what you would calculate using the calculation discussed, and the difference arises due to the fact that we're using some stochastic assumptions, the exponential distribution, to make it precise in the modeling exercise.